So, let's talk about 9.1. So, 9.1 is about a new kind of function. This is not going to be on your exam, by the way. Okay? Not on the test. Will be on the next test. Not on this one. 8.5 is. We're going to review on Wednesday.
You like a little bit today.
Yeah. Alright, so we need a definition. Okay, and this definition's scary, so I'm going to come back to this one. Okay. This is going to be for a thing called a polynomial. And I found out in the morning that this is scary. So is a function, and then we'll fill in the rest in a bit. Okay? So I'll leave a blank here. Let's fill in this easier definition. Maybe this is recall, right? What's a line look like?
F of x equals x plus c.
Good. So a line is a function like mx plus b, right? Yes? Smiling and nodding, I hope. Right? Slope, intercept. We've been and played this game a couple of times, I hope. All right. We should be able to recall another one. Let's see. A quadratic function is a function of the form you guys remember this one? Say q of x is
ax squared
plus bx plus c.
plus ex plus c. Good. Okay. All right, let's have one that's not a recall. So a cubic is a function of the form. So this is a new one on you guys. I'm going to call this c of x for cubic. And that's going to look like ax cubed plus bx squared plus cx plus d. You guys see the kind of trend here? Okay, so what do I have to do with x's to be able to evaluate functions like these? So this is my idea. I kind of want to, there should be more of these, right? This kind of could continue. And I'd like to say something like definition. Functions like these, right, are polynomials. The problem with this is that I need to define what I mean by like these, right? That kind of makes sense? So I'm wondering, what are the commonalities between these functions that I know, right? Lines, quadratics, cubics. If I were to continue this trend.
We're looking for a set of points x and f of x.
Okay, let's see. So commonalities, right? In other words, what I mean by like these. You guys with me on that? So let's see. There's a function, right? If I'm going to say it's a function at all, it better be a function to start with. Right? So it's got inputs and outputs. There's some kind of a rule associating those. But these rules are particularly easy. So what do I have to be able to do to calculate things like this? Okay,
Input.
let me give you a hint. Yeah, so if I had an input, what do I do to it? Well, there's multiply by numbers, right? This is something that happens in these. What I mean by this, right? I might go look at the red spots. The red spots are things like here. Here I'm multiplying by a number, right? You guys see all of these? You guys see that at the red spots I have to multiply by a number? Okay. There are natural number exponents here. You guys see those? Those are maybe green. Those are things like this. What's the exponent on x? 1. Is 1 a natural number? Yeah. So kind of, there's a 1 here that I'm really just thinking. I don't really even write it down ever. You see those? Then what else am I doing? There's only one other operation here, right? I have multiplication, I have natural number exponents, and
Addition?
yeah, and addition. And I don't have another color. Maybe this dark red will be different enough. Nope. So I'm not going to underline those then. You all see where addition occurs? Yeah. That one goes with these, right? You guys cool with that? So these are the only operations I need to evaluate functions like the ones we've described, right? So now don't panic here. Okay, I'm going to write down something that's a little panicky. Okay, calm. Be calm. Okay, so a polynomial is a function of the form, an R, P of x, right, polynomial, is a sub n x to the n plus a sub n minus 1 x to the n minus 1 Okay, now you're all panicking, right? I told you not to do that.
Oh my God, I'm panicking. I'm just ignoring. I'm not ignoring. That's the wrong word.
Uncomprehending?
Yes.
Bewildered? Okay, so why is this horrible thing happening to you? It's happening to you because if I continue this process, right, I'm going to run out of letters. You guys see that? Like here I was using 2 letters. Here I was up to C. Here I was up to D. Right? You guys figure out that eventually you'll be up to Z and then you won't know what to do with the next one? That's exactly what we're trying to avoid here. So instead of saying, well, we're just going to kind of keep going with letters at random, I'm just saying, okay, let's just organize it. AN is going to be the nth letter. Right? I don't have more than 26, but I can just call it something. So I'm just saying an represents the nth letter. You may have to make up more letters than are in the alphabet to get there. Is okay with that? Okay, so there's one more thing about this, and I need to put that here. N is a whole number. Okay, that's important. I don't want specifically to end up with square roots in here. You guys remember what a whole number is? Yeah, maybe. Okay, now we probably need some examples, right? Because I scared the bejesus out of you with this thing.
Yes.
Just remember, an is the coefficient on x to the n, right? Guys remember this? This is going to be a little bit like identify the a, b, and c for quadratics, right? We're going to play identify the a sub n's. Cool? Maybe? All right, so here's an example. F of maybe L of x, just to be suggestive, is 2x plus 3. Okay? Is this a polynomial? Yes. Why is this a polynomial?
Because it's a function, there's multiplication, and there's a natural exponent, and then there's a...
You guys see that? Because it has only these three things. Does it need to have all of these three things to be a polynomial? No. We can get away with a couple of these. But it needs to have only these things. Okay? So, if I wanted to identify the pieces here, there should be three things that I need to identify to call this a polynomial. Right? So I want to, wow, horrible bracket. So I want to think here, what are my three things? I should identify n, and then I should identify the a's. So what's the n for this one? What's the highest power of x that appears?
1.
1. You guys all see that? Very neat. Okay, so then there should be, okay, they start at a sub whatever the n was. So they start at a1 and go down to 0. So there should only be a1 and a0 here. What are they?
2 and
Yeah, so a1 should be the coefficient that goes with x to the 1, right? You see that? So what's the coefficient with x to the 1?
2.
It's a 2. What this one's asking, right, is what's the coefficient with x to the 0? In other words, what's the coefficient that doesn't have an x? That's 3. You guys see that? Okay. How about if we did another example? Q of x is a half x squared plus 3x minus 5. Subtract. Okay, so 1, is this a polynomial?
Yes.
Yeah. What's the maybe confusing point here?
-5.
Ah. Yeah, so there's a minus when there's a plus up there, right? Are addition and subtraction the same thing?
Yeah.
Yeah, they're the same operation, right? I can think about subtraction as adding a negative number. So I could really rewrite this as, instead of minus 5, I could rewrite it as plus negative 5. Okay, see that? So I might have to rearrange a little bit to get this to look like a polynomial. But as long as I can do that rearranging in a valid way, then it's a polynomial. What's the other thing that might be confusing?
The 1/2 in front of the x squared.
Yeah, that 1/2. That's still multiplication by a number though, right? I'm just multiplying by a half instead of, the integer. You guys okay with that? All right, so for this one, I should be able to identify the pieces. What's the n here? 2. Okay, then what's the coefficient on, what's the highest coefficient I should look for? A2. Okay, so that's the coefficient on the x to the 2, right? So what's that?
Negative.
That's,
Oh, no, it's not negative. It's just 1/2.
it's 1/2, right? It's the number next to x squared. Okay, how about A1 here? 3. And A0? -5. You guys see that these are the A, B, and C that you would get if you tried to. Sorry. Too small?
No, it's just
Sloppy?
some,
I can't fix it that much. Okay. Sorry. I'll write bigger. Okay. You guys recognize these are the A, B, and C that you would get if you were identifying quadratic coefficients? You want to see a not example?
Yeah.
Because right now you're probably convinced that most things are polynomial. Okay, let's just ask a few of these. So the question that we're asking is this a polynomial?
Yeah. Looks like it's supposed to be a 0.
Okay. So how about a of x is absolute value of x?
no.
Why or why not?
It's supposed to be q of x.
Because it's not one of the listed set of guidelines that was given.
Yeah, I erased them, right? But there were 3 things here. Those 3 things were multiplication by numbers, natural number exponents, and addition. Is this thing one of those? No. So this is a disallowed operation for it to be a polynomial. So my answer is no. Not a polynomial. And I'll pretty often abbreviate that poly. Okay? So this isn't a polynomial because it behaves differently, basically. Cool. Okay. How about, let's see. C of x is x cubed over 7 minus x squared over 3 plus 38. Is this a polynomial? Yeah. Yes. Okay, if it's a polynomial, we should be able to identify the n and the coefficients, right?
Yeah.
Okay, so what's the n? 3. You guys all see that?
Wouldn't there be 2 of them though? Because there's like x cubed and x.
Okay.
There's not going to be a 1.
Yeah, this is the highest exponent, right? Because they start at n and go down by 1s, right? So n has to be the highest exponent present. So let's sort your... So if n is 3, then where do the a's start? They start at 3, right? A3. Okay, so what's A3?
1, 7.
You guys all see that? So 7. really I'm thinking to myself, right? I'm looking at this thing and I'm thinking this is 1/7 times x cubed. Cool that? All right, what's a2?
Negative a third.
Good. It's negative 1/3 for a very similar reason, right? Okay, how about a1?
0.
Very good, guys. It's 0. For the same reason, right, that the b in the quadratic is sometimes 0. Right, there just isn't an x in here. So the coefficient on that term is 0. How about the a1? Or, sorry, a0. A0 is 30. Cool with this? Okay. Is there another example of something that's not a polynomial?
Square root in the
Square root.
exponent section.
Yeah, one of these guys?
Anyway, I guess, yeah.
This is not a polynomial. Why is this not a polynomial?
It's not in the guidelines. It's not one of the 3 things.
Yeah, so I need to convince myself that this is not a polynomial. And I want to think about why. Okay, so what were the allowed things?
Multiplication.
I can multiply by a number, I can add, and I can
Natural exponent.
natural number exponent. Is that,
It's a 1/2 exponent.
yeah, this is an exponent 1/2. 1/2's not a counting number, right? So when I look at this, I think, okay, this is x to the 1/2 power, and then I think 1/2 isn't a natural, right? 1/2 is a what kind of number instead? Integers are positive and negative naturals. It's not a whole number either. What is it? What kind of number is 1/2?
Fraction.
What's a fancy name for fraction? Or rational number. You guys see that? So 1/2 isn't natural, it's rational. Right, rational meaning ratio, right? You guys okay with this?
Mm-hmm.
Okay, you want the other one? So there's one more kind of thing we know how to do, and that's one of these guys. So I can divide by x, right? Except sometimes. When can I divide by x?
When x is 0.
Yeah, x is 0 doesn't make any sense in here, right? What's x is 0 doesn't make any sense in here a statement about?
Can't divide one sheep among 0 men.
Okay, I can't divide one sheep amongst 0 people, right? But what's that about? That's about an input that doesn't work, right? You guys see that? What are the inputs that work called? Starts with a D. We were talking about it earlier.
Domain.
Yeah, that's the domain, right? So what I'm saying by that is 0 isn't in the domain of this. You guys see that? Okay, so that's just something I kind of noticed. Does that have anything to do with whether or not this is a polynomial? Not really. So, is this thing a poly or not?
No.
No. Why not? I didn't say anything about dividing by x's, right? It just kind of wasn't in the list. If you want to think about this, another way you could think is you could think this is x to the -1 power.
That's not a natural.
And this is not a natural, this is an integer. You guys see that? You guys cool with that? Okay. Now we maybe need to try the next step here. So the next step up is we've got polynomial functions that look like this. Right? So far we have a whole little list of functions, right? So we've spent a bit of time adding to this list, right? In chapter 7, we spent some time solving quadratics, right? In chapter 8, we started adding to our function list. So we had lines, right? Then later we got quadratics. Then we got absolute values. Now we're getting polynomials. Right? Keep in mind that these two fit in that one, right? Is with me on that? This one specifically doesn't fit in there, right? Absolute values are not polynomials, right? That was up here, not a polynomial. Okay. So far we've got polynomials, and that includes some stuff. Today's goal is to add yet another thing to this, which is called rational functions. And these guys are going to fit in those ones. Okay? So, this should go a little bit like, remember when we developed numbers out of sheep, right? So here we're developing rules, right? And so our first rules were things like, okay, maybe we'll multiply by a constant and then add another constant, right? Y equals mx plus b. Then we started playing with, okay, what if we square it? Then we got, okay, we'll add lots and lots of powers together. Yeah? Okay, now, what's the next thing to do after you've kind of developed, as you're developing numbers, what's the next thing that starts with the idea of a ratio? Yeah, I mean, I have halves covered, right? I can put those in as the coefficients of polynomials. So what kind of thing can I do with polynomials to make what I would call a ratio of polynomials?
Negative exponents?
Yeah, I could really kind of add negative exponents. To do that, you might say, all right, a rational function is a function, say, r of x equals p of x over q of x, right? Where p of x and q of x are Okay, so remember when we built the rational numbers? We took ratios of the kind of preceding set of stuff, right? Here we're going to do the same thing. So we developed polynomials, and now we're going to take ratios of polynomials. You guys see this? So an example of something like this be, okay, r of x looks like, I don't know, x plus 2 over x minus 3. You guys with me on this? So this is really kind of thinking, all right, This guy on top, that's p. So I'm thinking x plus 2 is p of x. And I'm thinking x minus 3 is q of x. You guys cool with that? Okay, neat. Okay, that's a complicated example. Well, ish. Let's make an easier example. You guys remember this one? We talked about this just a second ago. Okay, so we said that before this wasn't this wasn't a polynomial, right? Now I'm telling you this is a rational function. We should have to convince ourselves that there's a polynomial on top and a polynomial on the bottom, right? Okay, so I'm thinking up here, 1 is a poly, right? So if p of x is 1, there should be some stuff for that, right? I should be able to do the same stuff we were doing a minute ago. So what's the n for 1? 0. And then there's just a0. What's a0? 1. Okay, cool. I'm good with that. You guys see that? All right, so how about the x on the bottom? We're thinking there, q of x is x. So what's the n for that one? 1. And what's a1 and a0?
A1 is 0.
A1 is 1, right? Coefficient on the x is 1. And there is no coefficient for the other thing, so that's 0. You guys buy into this? Over here, can I play that same game?
Yep.
What are the n's, top and bottom here?
1.
They're both 1. The a1 up here is 1, and the a0 is 2. Here where a1 is 1 and a0 is -3. You guys see that? Okay, now I have another question that I should ask. Basically, this is a dude what question, right? Like, we just learned this crazy stuff. Can we do any of the things we used to do with these? So, let me ask you a couple questions. So, let's try making a x r of x table. Cool with that? Okay. So, oops. Poorly drawn. Okay, so what are our 5 favorite points?
1.
Okay, so these are my 5 favorite points, yeah. So, I should be able to calculate r of these, right?
Yes.
Maybe let's add a couple more for kicks. Can you guys try to calculate these for a bit?
For which one? 1 over x?
R of x. So, right, this is a rule called R, this is a rule called G. For G, these would be really easy. I'm just going slowly along so you can check your thing. But you really shouldn't try this. You guys all getting these? Did I screw any of them up?
What's the R3 minus 5 over 0 question mark?
Because you can't divide by 0.
Yeah. What's that mean?
I don't know, your brain explodes or something? Really, that's not a defined value, right? So, if you put this in a computer,
5 nothing.
this guy will give you one of these nans, not a number.
So that stands for that.
Yeah, yeah, that's what nan stands for. So if you're in a computer coding class and see the compiler kicks nan at you, it's because you tried to input a string into a number variable. So this nan thing just means it's undefined. So if I was going to fill in my table, I'd get -2/3, -3/2, -1/4, -4, 0, undefined, not a number, whatever. OMG, this one didn't work, right? Somehow, right? This one didn't happen. And then this guy, I got a 6. So what does the undefined mean? That's really what I want to pick apart here.
There's no point.
Yeah, there's no output, right? You guys see that? That was an input for which there wasn't an output. So what's the deal with that?
So you don't use it.
Yeah, we don't use it. This guy tells you 3 wasn't in the domain. You guys see that?
So in that, when we used to have a hero wave, when we were defining the mid-range, there's a little bit in between that was like half a point. If we use something in that half, it would be undefined.
Yeah, so this guy here this guy's just 1 point. If I check close to 3, everything else will work. It's just this 1 point.
Right.
How do I know it's just the 1 point?
Because -2 has a thing and -3 is a thing.
Yeah, that still wouldn't be quite enough, but really, because those are on the other side, right? Those are negative.
Oh, yeah.
I could do 2 and 4. Those would give me a better feel for it, but those still wouldn't be enough. What I want to figure out is where the problem's coming from.
It's coming from the bottom being 0. And
Yes.
the only number that's going to turn that to 0 is 3.
Perfect. You guys see that? This problem, right, is because the bottom was 0. Right? That's when this happened. So, domain issues here. So, domain issues, really finding points that aren't in the domain, come from bottom equals 0, right? I can't divide by 0. So anytime the bottom's 0, I have a domain problem. So what does that mean over there? Well, it means that if I want to look at R of x is x plus 2 over x minus 3, this thing has domain issues when, okay, what's the bottom of this fraction?
Like r of x equals 0.
Okay, so when r of x is 0 is a different thing.
Okay.
Here I'm setting the bottom equal to 0, right? When r of x is 0, that's this guy, right?
Okay.
There's no problem there. It's when the bottom's 0. So it's when q of x, right, that polynomial on the bottom, is 0. So this thing has domain issues when x minus 3 is 0. Right? When x minus 3 is 0, that's the same thing as x equals 3. You guys see that? You want to try another one? Notice this didn't find the range. You guys see that? I found the domain. What's the domain? So r of x's domain is
Negative infinity to 3 with parentheses, 3 to infinity within parentheses. And the union symbol.
and a union symbol in between. You guys see that? It's everything except 3. There's another way to write that. We could write that as or big funny r, right? Minus 3. You guys see that?
Yes.
This is just different notation, right? Cool? So what's the take home? Rational functions are polynomial over a polynomial, right? And then we can spot the domain by it's all the stuff where the bottom isn't 0. You guys want to try one? Another one?
Yeah.
Okay. Let's try another one. So, find the domain of d of x is x plus 3 over x squared minus 9. Okay, so in the interest of time, what did you guys start with?
Find what would equal 0.
Yeah, you should find out when the bottom's 0, right? So you should set x squared minus 9 equal to 0. Okay, how do you solve this? Complete the square quadratic formula? Why not?
That would count.
That's way more complicated. This is already a completed square, right?
Yes.
So you extract the roots, right? So you add 9 to both sides, right? Get x squared is 9. Square root both sides. Get x is plus or minus the square root of 9. Which is plus or minus 3, right? You guys see that? So the domain on this guy, d of x's domain is plus or minus 3?
Positive. No, you're right.
It's the same thing as before, the r minus 3.
Okay, careful, right? We're spotting problems.
So
So
there's
this-
two problems in this, right?
Yeah, this one has two problems. You guys see that?
Yep.
So this is not a question about, right, this thing you get at the end isn't the answer. This thing you get at the end is the opposite of the answer. The answer is everything except what you just found. So you could write, and there's a bunch of these, right? One of these would be R except plus minus 3.
I'm not seeing the dx in any of the problems for section.
No, it's just a name.
It's kind of like f of x. We could use any letter we want.
Yeah, remember
Itself.
this thing is just a name. I named this d of x because the bottom is a difference of squares. We could have named it d of x because we were trying to find the domain, right? But it's just a name. So this would be one option. Give me just one more second. What's the other options here? So we could do r minus.
3.
You
Possibly
just put plus or minus 3 in there? Oh, okay.
Should put them both because you want to describe that there's 2 points that you're taking out, right? Or you could do intervals, right?
Negative infinity to negative 3, and then positive 3, or union
Negative.
3 to positivity.
And then you also have negative 3 to 3.
You guys see that?
Yeah.
We lost this stuff in the middle with this. So we need to put in, oh, it's not just the minus infinity to negative 3 and 3 to infinity. It's, okay, I got to go up to negative 3, and then there's a piece in between. All right, so there's a piece between minus 3 and 3. And then there's another piece from 3 to infinity. And I need 2 unions then. You guys see that? I would recommend when you're writing things like this that you draw some kind of a number line and go, okay, here are my problems, right? Let me just take those out, and then I can read off my intervals. Cool? All right, guys. We will do more review on Wednesday.